Tigers are never domesticated. Right, that's the truth. So they're never domesticated. All methods and constructors disallow any such change. All right, done. Okay, so in a second, I'm going to field a few more questions. So this one here, it sets the domestication status without an argument. All right, but this one down here, this one is going to set domestication status regardless of any argument. All right. Let me just save this guy here. All right, so that's most of them. And I think I'll pause and take a few questions. All right, what's going on?
Yeah, I was gonna ask, what's the point in writing public void set dom stat and then super set dom stat false and the same thing with the one under that if you already set it to false in the constructor?
What if somebody tries to change it?
It's just to make sure there's no one can change it, right?
Right, because I mean, if you call, remember, set dom stat is a public method, so it can be called by an outsider, and they can try to change it. In one case, if there's no argument, we're going to make sure that it's still set to false. But what if they try to change it to true? So in the second case, let's suppose they do put it in as true. It's still going to be changed as false.
Okay.
Right. So, I mean, you know, it doesn't matter what you say, the tiger will not be domesticated. Does that make sense?
Yeah.
Right. Okay. Let's see. And let's hear it, Connor.
Right. So I guess it's a related question to Jonathan's. I was also trying to figure out why we had the additional methods as opposed to just one. So I understand is to prevent them from making changes, but is that not the point of the fact that the actual data member is protected? Would that not be enough protection for the data member to be changed? I guess I don't quite see the connection yet.
So here's the thing. The data member was inherited. And in previous cases, if it's inherited, you know, it's gonna behave like a variable. What I need to do is to get it as close to being kind of like a constant as possible, although in the superclasses, it was always a variable. So that's why regardless of anything the user does, if they try to set the domestication status and they use no, they use no argument, then we're automatically going to set it to false. But even if they do use an argument, because they do have access to this whole thing, the best way that I can make sure that it stays constant, that it's always a false, is to make sure that anything that tries to access it will always cause it to return false. In other words, we're just going to reinforce the false attribute to make sure that it stays there, kind of like a constant, although it's not a constant. It started out as a variable from our superclasses. Does that make sense? It's a workaround to make sure that the false part is held as constant. Does that answer your question? Here, there we go.
Thanks, sorry. Yeah, thank you. I think so. Yeah. So we're reinforcing we're reinforcing that tigers cannot be domesticated by basically putting in multiple methods to make sure that the user can't do that. And
right, because the only thing, so in any other case, the only thing they can do is use get domestication status, or is domesticated, that function, but that's going to return false. And then if they try to change it, they're still going to get falses. So that's the way I'm working around, the fact that it was a variable in previous superclasses, but now it's understood to be a constant attribute. Like there's no such thing as a tamed, domesticated tiger in truth, So that's what's going on.
I'm just trying to, so that's making it clear then to me that the hypothetical user is able to basically override the sort of protected status of this is domesticated variable. Is that correct? So
here's the thing. So if it were like a cat, we don't know ahead of time if it is or isn't domesticated, all right? We don't know what type of cat it is. So in that case, we can still use that as a variable. It can be set true or false. But here with a tiger, you know better, right? So although the way it's declared was a variable that's inherited, every tiger that we create will not be domesticated. That's just a given. Every time you create a new tiger, the domestication status is going to be false. And every time you try to change that, no matter which tiger it is, you're still going to get falses. It'll never be true. So we're kind of closing the door on that. What was that?
I was following up. So does each of these methods correlate to each of the type of the three constructors we had in the animal class?
Well,
the three different constructors, the one was the default, one had, let me see. Yeah, one was just requiring the species, and then the last was requiring all four.
Right. So in that case, I created a bunch of, like a group of several different constructors based off of which attributes they would set ahead of time. So in things like cat and animal, we could try to set all of these facets ahead of time, or we could just choose to have no such argument and just use the default constructor from the superclass. However, whatever we do, we're actually making certain that there will be a cat object returned to our calling function when we try to use a new cat. And in addition to that, it's always going to have those same four parameters and fields, right? Now, whether or not we fill them all out, it won't necessarily matter, just as long as the constructor call is in one of these two forms. In this case, it's an empty argument list. But in this second case, they're all filled in, 1, 2, and 3, right? I could have put in there, cat, but it wouldn't make sense to like have a fourth argument in which, it's understood that it's going to be a cat. So that's how that goes there. When you create a cat now, you must use one of these two constructors, no others. You don't have any other choices. Otherwise, you get an error. Does that make sense?
Yeah, so I'm just trying to sort of connect the dots in between each of these classes. So when you work your way down to Tiger from cat, the methods within Tiger are going to address these two constructor basic instances, so that they'll always return false on a Tiger object.
Okay, so let's see. To tell you the truth, here's what I could have done. So let's suppose that I did something like that. It still would work. There's no errors here, right? I just use this Tiger class all by itself, and I'm just going to set the domestication status to false. That's no problem there. When I called the super class, I just basically did whatever cat's method would do, right? Now, cat for its own part calls a super class, which is this constructor up here in animal, right? But even if we have all three of those, basically with no arguments, you're going to be having simply the variables or the memory space returned to you that can hold a tiger and all of its different attributes, but has none of them filled out, right? So basically you would have all of your fields equal to something that's like 0 or null. It's just empty and not yet assigned. But that's why you also have your set functions in case you want to set things and change or modify some of the parameters. The only parameter that we're disallowing in Tiger, however, is the domestication part. I mean, species, I guess, also, but, domestication, you can't change that. So one thing I should make clear, however, is that this is not meant to be exhaustive. Like, I'm not saying, for every tiger, if you only give me 0 arguments, if you only give me 1 or 2 or 3, I'm not doing that. These are just examples. But even if I say omitted this whole thing here, it would still be roughly the same. There's, nothing that will stop it from compiling and having the same exact outcome. But some of my reasons for doing this was so that you can also see what some of your design options may be as you, write your own classes and subclasses. Does that make sense?
Yeah, that definitely helps. Thank you.
Right. So it's not meant to be hard and fast, but these are just examples of what you can do should a certain situation arise. One thing I didn't want to do is to try to be either too vague or too exhaustive, but some of these things should basically be a matter of good taste and good judgment on the part of the programmer. So that's what the goal there was. Now, here's something else that I can do. So let's suppose that I went back to take a look at the assignment. And in the assignment, let's just take a look at, let's see. I'll just reread it. So in assignment 1 docx, here's what I said. And I'll do a new screen share. All right, so it says the following. You must create the following files: dog, which inherits from animal; tiger, which inherits from cat; and Persian inherits from cat. These three .java files must also be accompanied by the appropriate both ordinary and java.doc comments. All right. So there's a lot of ways to go about that. I'll show you the simplest path. Here goes. Let me just do another screen share back to Eclipse. All right. So the first thing I'm going to do is, well, I already have Tiger up and running. All right. But I'm going to show you just how simple Persian and dog could have been. So I'm going to go up to my new button. I'm going to create a new class. All right. And that class is going to be a part of top down. Yes, top down is just right. But the name is going to be dog. All right. And the superclass is going to be animal. Okay. And I don't need anything else right there. So I'm going to finish. That extends from animal. So now I'm going to say the following. A dog is an animal. A dog is an animal object. And let's see. Also, I'm going to come up with Persian. So I'm just going to create another class. And it's going to be Persian. And its own superclass will be cat. All right. Okay. So now a Persian cat is domesticated. All right. So here's what I'll do. I'm going to say, let's see. Okay, so I can say the following: domesticated equals. Okay. And let's see. Let me just double check. Is domesticated. Sorry about that. And I should make this one a protected Boolean value. And let me just take a look at my syntax error. Might be that it has to be all caps. Let me just double check. No, it's not all caps. It's all lowercase. My mistake. Sorry. Done. All right. So when I did this right here, didn't work out so well. If I put it there, then fine. Now in certain languages, you'll actually be able to change from public to protected or private. But here's what they're saying. They're saying that the value of the field Persian is domesticated is not used. That's perfectly fine. I don't care. Let's see. Now the only thing I need to be looking at is, let's see, do I have an additional method that I want to use on it? So let's suppose I have a public Boolean function. And my Boolean function is what was I using before in my earlier classes? Let's just see. Is domesticated. Okay, I think I see a small problem. Let me just take a look. So that was domesticated. Is domesticated should be the method, not the variable. And just go back and change for domesticated, sure, that works. Then over here for this guy here, that works. All right. This should be normal domesticated. Okay. And let's see. And this right here should be domesticated. And now what I want to say is public Boolean is domesticated. And I will field some questions pretty soon. And I'm just going to return domesticated. All right. So now the value is used. This right here, however, should not necessarily be a big issue. Of course, they'll claim that it was never used, but it is used. But whatever. I mean, you basically inherit the function from the superclass, which is animal. I'm sorry, which is cat. All right. So this right here would be inherited. This domesticated would be inherited. And let's see, in cat, it was a public function. In my version, however, it is also a public function. But I changed the value of domesticated to be private. All right. Now, here's what I need to do. I'm just going to say the following. At return, the domestication status of the Persian. I'll put both caps there since they are both objects. And this right here confirms the domestication of the animal. By returning the private field. Okay. I can leave that as that. I can leave dog as this. And I think I will, let me just go and I'm going to generate the Java docs for these guys. Let me just see where that error came from. It was in no description for param D. Let me just double check. Oh, okay. So let's see the cat's name. And this would be the cat speed. And this would be the cat's domestication status. All right. And let me just go and see if there were any more issues. No, those were the only issues. All right. So Here goes. I'm going to try it again. I'm going to create the Java docs. All right, and this is for everything in top down. All right. So let me just pause this and here's some questions. But before we do that, here, I'll just show you what it looks like. When I go to the index of all of this, I'm gonna use index HTML. I'm right-clicking that, okay? Here, I'll do a different screen share so that everybody can see exactly what I'm doing. All right, so I'm here on index HTML. I'm gonna right-click that, and I wanna open it, but I'm gonna open it with my web browser. All right, so here's the entire package. Here are the interfaces that we discussed last week. All right, here are my classes. So here I have the animal class for creating templates. I think animal user, let's see, did I give that I should have given it a definition or some sort of description. I did give it a description. Let me just move this part up a bit. It's important that the annotations come second. All right. So the tags come second. All right. And let's see, I'll just try that one again. I'm gonna generate all of them. All right, and now let me just go back to index HTML. I'm gonna open it again. There we go. So now, there you have it. Animal users, the user interface for animals. To see what the subclasses are, Persian and Tiger. Now, if I go further up, just go to the package level. Here I have animal. All right. But one thing that's even more interesting is that when you have inheritance, you pretty much pick up on everything that the superclass had as long as it wasn't some private field or private method. So dog, although I barely wrote anything there, as you can see, they still have the constructor there. And let's see. And that right there is it. The dog's description is also there as well. All right, so I know people are going to be like, what is going on here if I don't stop? So let me field some questions. All right, let's hear it. I think you're up, Connor.
Sorry, I
Your hand was still up?
From last time, sorry.
Gotcha. Any questions, everybody else? Sure. Mm-hmm. Why wouldn't I? Okay. Well, I mean, it would have to be that you lack proficiency, not just a word choice, you know, and it really have to be like something where it's clear you didn't even try, you know. If a person shows signs of effort, they'll probably get the whole thing. So I guess that answers the question of what do you mean by all or nothing? Nothing would have to be something really, really horrible, or I just can't get people to follow instructions, or something really, really, let's see, bad. Plagiarism, that might also sacrifice a grade. But other than that, it's all or nothing. Even if you only got like half right or 40% or whatever, you should be getting credit for it, full credit. However, what the assignment should do is help you to see what it is that you don't understand so you can ask more about them. So it seems like in certain cases, students were not quite clear on, they weren't quite clear on, say, what it means to inherit from another object, right? So let's suppose that I had to show you, let's see, by way of, on the Dropbox, I've uploaded these folders here. And when we get back into discussing things, we'll take a look at thinking in objects, or there was this book called Thinking in C++, and although it's called that, one of the chapters about understanding objects in classes, I like it so much that I transferred it over here so people can, read it. It's in week 4, classes and objects. All right, so I guess some of you would want to take a break for now. How many people are trying to take a break?
Yes, I would like to.
All right, so let's see. Yeah, I'll give you till 8:20 since I did like an hour and a half or so. Is everyone ready? One person is ready. Okay, so last week there were some people who were a bit confused about what's the purpose of an interface, or what's the purpose of a of inheritance and things of that nature. So let's just take a look at the Dropbox. All right. Let's see. I'll do another screen share. So here we go. This is in Bruce Eccles' book, or Eccles' book, Thinking in C++. Now, we're not talking about C++ here. We're just talking about objects. So starting on page 23, he has something very interesting to say. And this is how you go about thinking about objects and inheritance and things of that nature. Okay, so he describes objects as being a combination of properties and the interfaces that work upon them, right? Let me just move that part out a bit. There we go. So now, let's suppose that we have to think of objects and how we use them. So what I told you before is that we use classes and objects to encapsulate information. So if you've been looking at the type of objects we've been creating, what you've noticed is that when we create objects, we are usually creating what looks like one big variable that holds smaller variables within it, right? And then on top of that, there's functions that behave on that variable, all right? So we say that these are abstract entities or user-defined data types that are a bit more abstract than, say, single variables like int or char or anything else, all right? So here's one way of looking at it, and this is the way we usually do look at it. We use classes and objects as ways of encapsulating information. So you can think of it as a covering for that group of properties, all right? Now, in certain languages that are object-oriented, they try to insist upon a particular type of policy. So Java claims that it is an object-oriented language where everything is an object. I prefer to say that everything is class-based in Java. There are other languages like Ruby where everything really is an object, including things like literals. So numbers can be worked on as well, even if they look like normal character numbers. Now, another thing is that we use objects to be able to describe very complex types of phenomena. So you think of it as follows. An object has the anatomy in which it is composed of smaller pieces or components. So like a human being would have 2 arms, 2 legs, a head, and all that other stuff. So objects also have, by their definition, the same components over and over again, despite the fact that you're making different objects each time, right? So the classification that 2 objects of the same type, like 2 cats, the classification that they fall into is the same, but the actual properties of 2 cats can be different. All right, so I'll say that again. The classes, they allow us to have the same definition for each object that is instantiated. However, the objects in their own right can have different properties. All right. So now, if these objects are user-defined types, then we could say that each of these objects has a type. Or in other words, you could say that they are cases or instances of the classes that describe them. So a cat is an instance, or a cat object is an instance of a cat. Here, let me show you. We'll go into Eclipse. All right. And let me just go into, there we go, Persian.java. So every Persian is also a cat. That's not to say that every cat is a Persian, but every Persian is a cat. So every subclass is a case of the superclass, right? What's more is that when we actually create these objects in our main functions or in our main method, you'll notice that in this particular situation, we also have the following. We created a new animal, right? An animal has all the properties of any other animal object. So A, A2, and A3 have 3 different definitions. However, they have the same uniform properties. So each of them is going to have a name. Each of them is going to have a species. Each of them will have a domestication status and also a speed that the animal moves at. However, although each of them have those different properties, those properties are not guaranteed to have the same identical description. So the species of an animal doesn't always have to be cat. It could be a dog as well, as you've seen. Both every cat and every dog are in turn animals. And you could also say the same thing about subclasses of other subclasses. So tiger is a type of animal as well. It's also a type of cat. All right. So now, moving back to what he had to say. So if we have objects that are the same type, they can basically interact with one another, right? So they can pretty much pass messages, and this can vary from one language to another. In C++, it's not as uncommon as it is in Java, but objects can, by means of certain types of methods, be able to speak to one another. Now, since we have the idea of data members pretty well in place, then the question is, why do we have the methods? And the methods allow us to work upon those data members, whether we're retrieving them for reading or if we're writing to them. All right, so you could think of it as an IO interface. It's a user interface with the data members of that class, which are in turn data members of each object that's instantiated. So now, last week, I told you that we can't always expect an object to fall within a particular type of class simply because its behavior is similar. So when we have a behavior that is common to more than one type of object, we usually try to consider that to be an abstract interface. Now, normally your objects will have their own interfaces. The interfaces are originally the set and get functions. However, when you have an activity that can be shared by quite a few different objects, for instance, if you have, say, movement, right? Movement using wheels. A bicycle moves using wheels, as does a car, as does an airplane, right? But that doesn't mean that all three of them are the same type of vehicles. What it does mean, however, is that when they move in that particular way, they are pretty much doing the same activity. So they're moving or driving forward using a wheel as a form of transportation or mobility. All right. So when it comes to objects, we say that objects have an is-a relationship. In other words, the same way that every cat is an animal, so every tiger is a cat, right? They are a case of their superclasses. Now, one thing you're probably wondering is, how do you understand what's being inherited and what is not being inherited? Well, in most programming languages, when you perform inheritance, you can inherit both public as well as protected data members, but you can't inherit private data members, all right? So let's just take a look at what we have here. Here we have a simple UML diagram, right? And here we have an object. The object is called light. But now right below that, you have what you would call an interface, or the group of methods that act on that object and that describe it and its activities. So a light can turn off or on, it can brighten, and it can become dimmer, all right? That's what would be in the actual light class. Once we make a light object, that object can turn on or off, and it can also brighten or become dimmer. So now you're probably wondering, in this particular case, what does this have to do with things such as the interfaces you've learned about last week? Interfaces require that we implement them in a particular class. So we actually mix in the behavior that that object should have simply by belonging to a class that implemented the interface that was abstract from before. So to put that into context, if I say that every marine animal swims, that's not to say the same thing as every fish swims. You see, suppose that I say that I am thinking of a penguin and its ability to swim. Well, then I'd be sorely mistaken if I thought that everything that swims is a fish, all right? The same way I would be mistaken if I said everything that swims is either a fish or a mammal, accounting for things like dolphins and whales. But there are actually other types of animals that can also do the same thing. So we have an interface that describes the actual behavior of the object in question, all right? However, it does not interfere with the classification of that object. So now, when we inherit from one class to another, we don't really have to take on the task of redefining all of the different set and get methods or all the other public or protected methods. Those things are added on to our subclass, all right? The only thing that does not get inherited into our subclass is private data. So now, let's take a look. Here we have a case of a has a relationship. A car has an engine, all right? Now, in this particular case, what you have is something called composition. And it works like this. Certain classes and objects can, for their own part, hold still other classes or objects. So if engine were an object and car were an object, we could say that car is not only an object, but that has an inner object inside of it, namely the engine object. All right, so that is has a relationship. A car has an engine. So now, what about the case of when we are inheriting? We talked about the is a relationship, where an object is a case of that class. And we also talked about the is a relationship in the event of inheritance. But now, notice what he has to say here. So this is the part that you want to keep in mind. It says the following: it seems a pity, however, to go to all the trouble to create a class and then be forced to create a brand new one that might have similar functionality. It's nicer if we could take the existing class, clone it, and then make additions and modifications to the clone. This is effectively what you get with inheritance, with the exception that if the original class, called a base or super or parent class, is changed, the modified clone, called the derived inheritor subclass, also reflects those changes. I'll repeat that again. Inheritance is like making a clone out of the original class, or out of the original class. However, it has the slight exception that if we were to change the superclass, right, then the subclass would also have some sort of carryover from the change in that superclass. All right, so let's take a look. Here you have a derived class and it inherits from a base class. That's what that arrow there means. And this is in a notation known as UML. Okay, so moving forward, let's take a look at the relationships between derived and base classes. Here we have something called shape. All right, now shape seems to be a bit abstract. There are many shapes on Earth, and quite a few of them we could think of. However, take a look at what we have here. We have 3 different classes inheriting from a superclass called shape. Now, in this particular case, circle is a shape, square is a shape, and triangle is a shape. But there's more to it than just that. As you can see, circle, square, and triangle have no additional details to them. However, they still do retain the methods that they inherited from the base class. So things like draw, erase, move, get color, and set color would then be copied over into the classes or into the objects of the subclasses and subobjects. All right. So a circle can draw, erase, move, get, or set colors. Same thing with triangle. However, one thing that's important to note is that although they are all classes, I'm sorry, not all classes, although they are all inherited subclasses from that particular example, it doesn't mean that they all have to behave in the exact same way, or that they all have to be classified with regards to one another. A triangle is not a square. A triangle does not have a square, and a circle is not a square, right? So in that case, you have to understand that inheritance is going up in a vertical manner. Now, the next part, take a look here. This is a good representation of what happens when we're using inheritance. So we have the same shape class from before, but now take a look at what triangle did. They added two methods. One was called flip vertical and the other one was called flip horizontal. Those are the two additional methods for triangle. Now, here's what that means. Triangle now has two new methods that it behaves off of. However, those new methods are not part of the superclass or any sibling classes like square or circle. Right now, square has about 5 methods that we're aware of. Both square and circle have about 5 methods that we're aware of, but triangle has those 5 plus 2 more. So they have 7 different methods in their interface. So now you've seen me say a few words about overriding the behavior of a superclass. All right, let's take a look at shape a little closer. Notice how now you see a listing for classes, I should say classes, but methods that were found previously in this superclasses API. So now circle has its own draw and erase function or method. Square has its own draw and erase method, and so does triangle. All right. Now, the fact that they have their own distinct function in that scope would mean that they have redefined the behavior of the function so that it most likely won't be identical to the others. Another thing is that those definitions are now going to be much more bound to the subclasses that have defined those methods, all right? So overriding functions allows you to choose between, or I'll say that it is the choice of creating your own methods such that the previous methods, the general ones, are overridden, all right? They no longer share the same exact, how would I put it? The same exact features. For instance, if there were a method called getArea, all right? In shape, getArea might be abstract and hard to actually make a definition for. However, in circle, we know that the area would be pi r squared. In squares, we know that the area would then be side by side, right? One side times the other. And with the triangle, we know that we have 1/2 the base plus the, or 1/2 base times height, all right? So in those cases, we will override the abstract method that was in our shapes class. So now there are a couple of other instances in which you may find yourself trying to make some sort of sense of different types of objects that may travel together and seem similar. In this particular case, you have something called the is like a type of relationship, in which it's close but not quite. Let's take a look at the example. So here in this example, we have the following. We have a climate control system in which there's a cooling system, a heat pump, an air conditioner, and a thermostat. Now, if you take a look at what these arrows say, the thermostat controls the cooling system. All right. Now, how do we do that? Take a look. We have a method called lower temperature. And then once we're controlling the cooling system, that cooling system can actually run their cool method. Now, in addition to that, you also have an air conditioner and a heat pump. Now, the heat pump may sound like it's, well out of the way, right? But let's just take a look at this scenario. So now the air conditioner, let's suppose it breaks down and we try to replace it with a heat pump. And the heat pump for its own part can hold both hot and cool mediums, right? Now the heat pump is like an air conditioner, but it can do more because the control system of the house is designed only to control cooling. So it's restricted to communication with the cooling part of the new object. The interface of the new object has been extended, and the existing system doesn't know about anything except the original interface. All right. So in this case, you have derived objects or derived classes that for their own part may have such a definition where they're no longer completely safe drop-in replacements for similar objects. All right. So now we'll talk about polymorphism a bit later, but you've already seen it. You've seen it in the form of method overriding. And there's also a different part called method overloading, and you've seen that as well. Now you're probably wondering where. When we inherited, we were using a polymorphic, you might say, type of behavior when it comes to objects that are subcases of other objects, right? So the way that a cat behaves indoors and the way that a Persian behaves indoors and the way that a tiger behaves indoors may, for its own part, throw us off if we try to compare the actual behavior to what we would expect of the average cat in either extreme. All right, so in that case, what you have is the following. You have methods that have multiple function calls, and the calling for its own part, when we have those methods with multiple function calls, we're actually going to choose which of those methods should be executed given the circumstance or context. All right. So it's going to be about circumstance or context of our language or context of our problems that we're trying to solve. Okay. So now, I think that's enough for now. How many people get what I'm saying 100%? Let's just see some hands. Okay, so now, questions. Let's field some questions. Anybody? I have people who say that, let's see, they're 85% sure, 75% sure. What's going on? Here, I'll pause the video. Let's hear it. Let me just unmute everybody. Okay, let's hear some questions. Connor says 75%. How come?
I mean, I think with practice, I'll fully understand it. I never fully understand the concept until I actually implement it myself. But the explanation you gave made sense. That textbook made sense. I like the diagrams. But again, I'm never fully confident in myself until I am actually able to execute something personally.
Okay, Rafid, Mr. Kareem, what's going on? 85%.
Yeah, sorry. Hello, can you hear me?
Yeah, I can hear you.
Yeah, exactly as Connor said, I understand the idea behind it. I understand the uses. I simply just need to actually execute it. I feel like it better helps me visualize it whenever I actually try and I actually code something out, because then I understand like the little intricacies behind it, like why a certain thing you have to do a certain thing a certain way for something to work.
Okay. Let's see. Nazmo.
Yeah, pretty much the same.
Okay, pretty much the same. All right, so here's what we should do. Let's try a let's practice together. All right. And so we're gonna do as follows. I'm gonna create a geometry program, and there's gonna be a 2D and a 3D. All right. So here we are, starting a new project. Now, let's take a look together. All right. Here's what we're going to do. So, going to come up here and I'm going to go with a new Java project. And this one's going to be called Geometry. All right, that's my project. Now let's see, I can use, I think I'll just go with my default right there. Okay. And from there, I'm going to hit finish. And they want to create a module. I think for now, I could forego a module. Let's suppose that I did have a module. Okay, so it's going to be mod.geo. All right. So now, in this module, I'm going to do the following. I'm going to create a new package. Here we are with geometry. right here on the left-hand side. You can also see I have my system library there. I now have my source files, module.info.java. That's not going to really bother us too much. So now, beneath that, I'm going to do the following. Within a module can be many packages. All right. So I'm going to start with a new package. All right. And I'm going to use, let's see. Okay, so now within my module is going to be a package. And so I said I want to name my package basically with my URL backwards, all right? And I'm going to just say the following: geometries. Okay, that's going to be my package. Also create package info. Okay, so there's my package right there. Now, packages for their own part do the following. With that package, I can now create some classes, and I'm going to do just that. So coming up here, I have a new class. And this class right here is going to be called shape. Now, a shape can be just about anything. And because of that, it's going to be hard for us to say ahead of time what that shape will be. But here's what I can do. I can say the following. I'm going to make the following adjustment. I'm going to say that I put this in geometry dot toDim for two-dimensional. And now I'm going to hit finish. All right. So up here, you can see that I had a somewhat larger, right over here, you can see that I had a somewhat more general package. And then now I have a different one down here. It's a bit larger. I have shape there. Okay. And now shape has the following. I'm going to do the following. I'm going to create a class that is not going to be completely defined. So here's what I need to do. If I know that I have a bunch of methods that I want to inherit from, I'm going to have to create those methods and then try to make some sort of a standard API for how we're going to use our geometry calculator. So here's the next thing I need to do. If I want to create that type of function or method, but I want its behavior to be delayed until the appropriate time, because say the area of a triangle and the area of a circle are not one and the same, what I need to do is come up with something that's abstract. And I can do it as follows. Abstract, all right? And going to have the following. Get area. And this is going to be a public. A public type of method. But now here's something else I should tell you. The minute I have this abstract function, I'm going to have to do the following. I'm going to have to change this class and declare it abstract. as well. So abstract class shape. Now, what this abstract class means is that it won't ever be personally, or you might say directly in a first-hand sort of way, instantiated. So there won't be any such thing as a true shape object. Now, for this method here, I'm going to return a double. All right. And just like that, I now have an abstract class. Now, the other thing I want to put in here is public abstract. All right. And for public abstract there, I want to say the following: double. And for double, I'm going to say perimeter. All right. Put my semicolon there. And as you can see now, I have myself a pair of items that can be used for my abstract class. All right. Now I can also put in here a constant if I wanted to. But I tell you what, I won't put it in there just yet. So now that I have abstract class shape, I can also comment it. Okay, so shape is a template for all shape subclasses. All right. Just like that. Now I'm going to come down here. I'm just going to say the following. So two-dimensional get area methods. Sorry about that. So it's going to get the area of our two-dimensional shape. But this is going to be in the subclass. Okay. So get area. Let's just say calculate. This right here should be get perimeter. I'm sorry, guys. Get perimeter. Okay, so get area. It's going to approximate the area of any two-dimensional object. So any shape object. Okay. So with that, I'm done. And so here's what this here concept is all about. An abstract class is basically a class that we have set up that will give us some sort of a outline for other classes to inherit from and to actually create their own behaviors based on. All right. So now the abstract class has two major, what I would call prerequisites. And the first prerequisite is that we must declare our class to be abstract if any one of these methods happens to be abstract. If it's just one, that's enough to declare the entire class an abstract class. Of course, I can have an abstract class even if I did have methods that were already defined. So that doesn't really stop a person from using, methods from an abstract class, but abstract classes were meant simply to be hubs that can be inherited into a base class. I'm sorry, not into a base class, into a derived class. All right. So now, in addition to this, I could have had an abstract class without any sort of, abstract methods. But basically, what this means is that I won't be instantiating, I won't be creating an object of type shape. So now, let me just make a new one. All right, and this is my class. My source folder. Here we go. So in this particular case, I want to create something called square. All right. Now you'll notice that down here they have words like abstract and final, whatnot. I'm not gonna get into that part right now because it'll probably do more to confuse a newcomer than to actually help a person progress. So public class square. Now square for its own part is going to have to do the following. I'm going to have to create in square a method that actually does compute its own perimeters as well as its own two-dimensional area. So I'm going to say that square extends it's going to extend shape actually. All right, so let's just take a look. So now they're telling me that I need to create those undefined methods. So here we go. Public void. Well, no, I'm sorry, it shouldn't be void, it should be public double. All right, and the reason why is because in shape, there was a public double get area, so public double. So now here's what I'm going to put in here. You can say the following: return side by side. Now, right now, that won't make any sense, but I can make it make sense by doing the following. This is going to be, let's see, should I protect it? I'll make it private. Okay, and private double side will simply be an element. Now, if I want to create my perimeter function, which I am going to have to do any old way, I'm going to say public double. And let's see, because it's double, I'm going to use get perimeter. Okay. And with get perimeter, I'm just going to return the perimeter. So for square, my perimeter is going to be 4 times the side. Quite literally, side plus side plus side plus side. Okay, and with that, I now have my subclass of shape. So let me just put some documentation in here. Okay, so square when instantiated will create objects and those objects will correspond and they're going to correspond to the abstract class. Okay, so this guy here can be instantiated, but his superclass cannot. So it returns the area of the square. Down here, I'm going to say something similar. The perimeter. There we go. And get perimeter. And I think I have to make this clear. This is just for two-dimensional objects only. I believe I'll save that. Now, there's more that I could do. All right. Let's suppose I had the following. Let's suppose I had a class called rectangle. So I'm going to make a new Java class. This guy here is rectangle. I just want to make sure that this one here is going to also inherit from shape. Now that we know that it's extending another class, I'll do as follows. I'm going to say that this guy extends shape. I'm also going to borrow it's going to return the area of a rectangle. This is going to be the perimeter of the rectangle. Okay. And down here, same thing, rectangle. Okay. Now, here's what I really need to do. I'm going to come down here and I'm going to say I have private double length Okay, now I don't know what double length is going to be equal to yet. I also know I'm going to have a private double width. So double width. All right, now here's what I want to do. Here, I want to say this is equal to length times width. So length times width is in one case. And in the opposite case, here's what I have. So here I need to do the following. 2 times the width plus height. Sorry, it's width times length. I should have put length in there. Okay. So now, let me just make sure of the order of operations. Okay, so now you're probably wondering what becomes of square. All right. So let me just pause right here. Well, actually, no, I'll just take it one step further. All right. Here's what I'm going to do. I'm going to say square now extends rectangle. Okay. And I now have my side by side and my 4 times the sides. Okay. Now, let me just pause because I see some hands going up in the question box. And let me just unmute everybody. All right, everybody, let's hear some questions.
Professor?
Yes, sir.
I don't think the get perimeter equation might be correct for the rectangle class because
Okay, let's take a look. So with rectangle, right, I need to add up everything on the outside. So I have a width and a length, and I double it because I have 2 widths and 2 lengths. What?
Yeah.
You said what now?
So it's I believe the equation for perimeter is 2L plus 2W. But if you were to do it like 2 times width plus length, you will get a different answer than 2 width plus.
Yeah, dude, you'll get the same answer because you distribute the 2 in, it becomes 2 width plus 2
distributed.
Yeah, that's the same this is just basic algebra.
Type it into a calculator, you'll get the same answer.
No,
2 times the width plus 2 times the length.
So what I did width plus length. I didn't distribute.
That's the same thing.
No, because I just did width plus
Width
length.
Plus length and multiply that by 2 will give you the same answer.
Okay, so let me just.
I just did 5 plus 2. I just did 5 plus 2 times 2, and I got 5 plus 2 is actually no. I'm tripping. Yeah, you got it. I just did that one.
Okay. So, all right. Interesting. See, this is why I paused the video.
I got a question.
Yeah, sure. How's it go?
So if we're still gonna end up having to retype public double get area, public double get perimeter, what's the point of making the shape class if it doesn't save anything at all? You're still retyping the methods and you're still changing what's in them.
That's a good one.
It seems like it didn't save anything at all.
So remember, the abstract class, first up, I know that there's a certain API that I want to have, even if I don't know what type of shapes I'm going to use. So things like get area, get perimeter, when it's this far out, even if I extend it with triangle or circle, things that are like very, very different, they can all have the same interface. So if I'm making a specification for
you're still typing out public double get area, public double get perimeter, and changing what's in them. So if you were to delete extend shape right now, it wouldn't change your code at all. You would be
but what it does is it adheres to a specification. So if I know that I have a larger project and I want the behavior to be uniform, then the best way that I can make sure that the behavior is uniform is to try to either use a subclass that will be, derived from a major superclass, or I may type in some sort of, I might use like an interface, right? But here's the thing. Remember what I told you about the definition of an abstract class. So the abstract class, for its own part, this right here tells me exactly what I want to do with all 2-dimensional objects, right? So if somebody else comes along and tries to alter my work, in order for them to add anything to it, they have to adhere to this standard. Now, another thing is that let's suppose that abstract class shape was not necessarily defined the same way. You see, if I knew ahead of time that I would have a circle, I could literally do the following. I could take that out and actually go so far as to define the method right here. And then I would say something like math.py. All right, this guy there. All right, times. And then I have like something like a radius, And so the thing is that you can indeed place in here, different types of objects or whatnot. If I have a radius, let's say the radius is, let me just put in double.
But then for every other shape, you would still need to retype public double get area and change what's in there. So it just doesn't seem like it saves you any code at all. And
well, it depends. It depends.
Even if you say that they adhere to the same standard, the standard is only the same because you're retyping everything.
So that part depends. Hold on, let me just, I'll say that this is private double or protected double. Okay, so I have a more flexible class that I can either put some sort of default functions in, or I can simply use it to create some sort of pervasive standard for my entire software system. Now you're saying that I would always have to add things in. That's not true, really. I could have done the following. Let's suppose that this were rectangle, all right? And down here I have square. With square, I could do the following. I could just say the following. Return super, and let's see, get area. And then I just put in my arguments for both of them, as in side by side. All right, so let's suppose that over here, let's see, in that square, so in rectangle, if I had a rectangle type of constructor, all right, and somebody gave me a, I'll just say this is double L and double W. Okay. Now I have the ability to really transform some of these things into terms of other types of classes. Now I know you're wondering, like, well, how come we're using this when perhaps you're just going to change this thing or that thing or the other? Well, here goes. Let's suppose that over here in rectangle, I had defined things like a print function, a set and a get, and the only thing that I really needed to do was to change the area. So if the only thing I really needed to do was to change the area, then I actually be saving on code, because I have a much larger API, but I'm only changing a fragment or two here or there. So when you think about it, you see a square is a special case of a rectangle. So I can use the rectangle to do the square's work. I just have to take the square's characteristics and transfer it over. If a circle is a special case of an ellipse, I can still use ellipse functions. I just have to take the characteristics of circle, which is a radius, and then transfer it to the superclass. So I'm really actually able to benefit greatly from, at one point or another, being able to have code that is reusable. Now, I know you're seeing me constantly like changing things, right? But my reason for why I've changed this one here is because I actually need to. My reason for doing it here is that, you see, I could have square having a length and a width, right? And if I did that, that would be perfectly fine. I just have to have length and width equal to one another. However, I can save on the fact that I don't need things like, you know, set and get side or set and get length or width. I can actually start to minimize what has to be repeated. So right now, it looks like a lot of things are being repeated. But in other cases where programs would grow a bit larger, you would start to see how you can actually not reinvent the wheel, but take care of the special cases. So the special cases are reasons for using inheritance. I know, like, for now, it doesn't seem so straightforward, but there are some really good reasons for it. More questions. Let's hear some more questions. Jonathan, your hand's still up. Do you want to still ask something else?
No, I just didn't put it down. My bad.
No problem. So here's what it is. I think that, like right now, it might be a bit more difficult for you to see it from this angle. I think it becomes a bit easier once you see how a concept such as polymorphism works, and how you can actually start to have smaller and smaller class definitions. Remember what I had with dog over here? In this case, I didn't really need anything for dog, and I could still instantiate a dog with this class here. I already have everything that I needed from animal, right? So I can use rectangle and square, not just to borrow from one another, but to create other classes like, say, cube or rectangular prism. I can also reuse rectangle for things such as a cylinder or, let's see. Yeah, I can use things like rectangle or circles for things like cylinders. I can also use them as well as, triangular components for things like pyramids or square or triangular prisms or cones. So one, it allows me to have a uniform means of operation. And two, if I, choose to design things a whole lot differently, I can indeed get away with writing far less code. For instance, when we did the Tiger class, Tiger didn't have to have everything from cat or animal explicitly added in. Instead, all it did have was the domestication status change, right? But everything else, you was able to use it. It was already good to go. Does that make some sense about the reusability? Come on, peoples.
Will we see an example at some point later on in the semester where we'll have like a larger program so we can see possibly where the inheritance would be more applicable?
Sure. I mean, I hope so. And I intend to. Yeah, I mean, that would be fairly, that's not asking a lot. But here's the thing. So what I want you guys to understand is that when we are using objects, right, in certain cases, depending on what type of object we're trying to classify, we can have extremely abstract user-defined types that help us to group together a large variety of different but interrelated subjects, right? Now, last week, you were wondering, well, what's the purpose of an interface? And the interface was to actually add things in, help you to add in certain types of behaviors. So yeah, it's possible that I could use things like an interface to stir in those types of functions and whatnot. Or in certain cases, I may want to use an abstract class because not only does it help me with the API, but it also helps me to bind the subclasses into a certain specific domain. So they'll have some sort of application specific advantage. Let's hear some more questions. Nobody. All right, so here's what I want to do. And let me just make sure that I can kind of get around to it. So I have shape, I have square, I have rectangle. Let's suppose that I am actually going to, you know, like totally go for whatever, whatever you say in that regard. Here's what I'll do. So in rectangle, I have this as my constructor, all right? I'm just gonna say that length equals L and width equals W. Right, so length equals L, width equals W. Okay, and that part is taken care of. Now let's suppose that I did the following. You see here I have private double length and private double width. I could do the following. I could take in for square, I could take in an argument. This would be double. And double S for side, all right? Then I could say that side equals S. But I can also say, in addition to that, super S. All right, so yeah, I can do things like that. So, some of these things are going to be a matter of taste and design. And I'm not going to say that, I can guarantee you that because you don't see things immediately, that these things won't come up as necessary utilities. One thing that makes this whole thing important, interfaces and abstract classes, is one, we have largely expandable code, and two, we also need to use interfaces and abstract classes wisely, because in Java we can only inherit from one class at a time, right? So although I can have square inherit from rectangle and rectangle inherits from shape, in turn I can make certain that my square is going to have all of the functions that I need for me to have a working calculator. And also I can make sure that other people don't break my code. But in addition to that, I can also then start to use some of the more concrete functions that were defined in previous subclasses. What I should tell you and make sure that you guys know this is that when an abstract method has its body defined, that abstract method, or what used to be an abstract method, would now become a distinct concrete method. And if for its own part, would allow us to be able to tap into one of the previous definitions without changing the way our current interface looks, namely the IDE or similar development environments. Okay, so yeah, there is a point to all of this, but small examples, I understand that that may not help as much as you want it to, but it can help. Just it may be harder for you to see it at first. There's somebody in the chat box. Can I go back to the squared class really quickly? Okay. By the way, Connor, does that help somewhat?
It does, yes, thank you.
Okay, no problem. You know, here's the thing. Here, let me see if I can show you. Let's suppose that we are a bunch of different vendors, and I'll get back to that question about showing that information. But let's suppose that we're a bunch of different vendors, and we all have to adhere to, you know, the following standard for a language. You know, proprietary stakeholders may not want to cooperate, but even still, if there's a standard, that standard can be used pervasively so that people who don't even see one another's code can build code for the end consumer that will easily interact with, you know, somebody else's code in which they attempted to do the same thing. So, you know, you have drop-in replacements that will be useful even if you get them from different vendors or designers. So one thing I was looking up earlier was the IMG file. Let's see, .img. I believe this is it. It should be a myth. There we go. So in the case where you have ISO images, you have a bunch of people not working together, but they're trying to live up to the same standard. All right. Another thing is that it may also help a new programmer see the code in a way that's much more readable. But also, most notably is the fact that, you know, different types of standards are almost indispensable. So if I had something like ISO C or ISO C++, you would have an entire interface on what it is that you should be, devoting your time to, right? So let me just see if I can pull up the ISO standard for C programming. Here we are. So as you can see here, once these different standards are established, if it were overly commercial, that could lead to contention. However, if you have like a standards body that was telling you to, stay within certain boundaries, then your attempts at code reusability would go somewhat farther, right? It would go a longer way. So now, what I get that. I think that what I have to do is, after making some of these shapes, is to show you how they behave around the main function, in which you can then, be able to make some sort of, I guess, conclusion on whether or not you see the utility in having things like, whether or not you see the utility in having things such as different types of data types being assigned to other data types that you perhaps did not expect before. I could have, say, a square object and then say that I'm trying to set up a new rectangle, right? But that's some years off. And I hope that, until then, you all will make very good design decisions that will, allow you to, if necessary, pick up where you left off at, but also to be able to roll out software a whole lot faster due to there being quite a few hosts, or quite a few different people who are trying to perhaps supplant another company, or trying to look out for their own monetary gain. So, these are tools. You got to use them wisely, though. And I think that's the part that most people may not understand. Because on the surface, it looks like one thing. But when you look at it a little bit closer, you can kind of see, what some of your options are and how they can be used in a very clever manner. So it's going to require some ingenuity and some inventiveness, but yeah, these things are, they're worth paying attention to. It's a widespread practice to have reusable code. Any more questions? Okay. None, I suppose. No more questions. Okay. So yeah, I can use superget area. I can also do the following. I can make sure that private and or I can make sure that length and width were protected. So if these two are protected, and now once they're protected, I can then just use them synonymously so that square can be minimal. Now up here, get area had length times width, but for the actual rectangular part, I had added in SS, right? So in this scenario, I would probably want to have in one of my earlier classes another function that will help me to balance out different, to really help me to balance out different means of using inheritance to safely transfer some of the code without creating all sorts of malfunctions later on down the road. But this is basically what you would be doing eventually with some of your classes. If you have interfaces or abstract classes, you have to then start to instantiate some of these classes or objects later on down the road. So let's see, chat says what? Could I go to the top of the top of the square class? Yeah, sure. Okay, peoples. So I tell you what, I'm gonna wrap this thing up, and I am going to, I guess I'll figure out some sort of homework perhaps. One thing I wanted to get around to doing was including one piece of code in the other by using the Java's, oh boy, what was it? I wanted to be able to give you an assignment that would allow you to use this material here. And I was going to have a three-dimensional object that would then build off of the two-dimensional ones by importing the package. So that's why I put them in such unusual package spaces. Can we get something like an ungraded exercise for this? Yeah, sure, I will. No problem. So with that being said, it's been wonderful. I'll see you next week. Do well in your other classes. And in a few days, enjoy your weekend. All right. You are dismissed.